Okay, so number 13. I didn't make the pretty picture like they have in the book. I didn't bother to draw this out as a tree, but this is a pretty tree. And that's the tree trunk there, so that should be brown. But whatever. The tree is growing on the hillside, and we know a few things that are happening. We know that that it casts a shadow that is 18 meters long, and we know that the angle from the tip of the shadow to the top of the tree is 68 degrees, and we know the tree is growing on a slanted hillside, and the angle it makes with the hillside is 16 degrees. And we are trying to figure out how tall the tree is. Any bright ideas? Set it up like two triangles. Okay, so Abby is pointing out that we know that if this angle right here is 16 degrees, then this angle right here is 16 degrees also. Is that not correct?
That's true.
That is true. And why is that true? What are those two angles called? Corresponding angles with parallel lines, and we know that those are congruent. Okay? Good deal. So you said what now? All right, so this right here is a 90-degree angle. So I could find out this part right here. How would I do that? All right, so if I go sine of 16, that would be the opposite side, which we'll just call x, because we're feeling creative, divided by the hypotenuse, which is 18. So that little piece of the tree would be 18 times the sine of 16 degrees, which is what? 5, exactly. About. The boot, 5. So this little section of the tree is about 5 meters tall. It's quite the big tree trunk. Okay, so that's part of it. Now what? Okay. Oh, okay, so now she's going to go cosine 16 degrees equals, so you want to try and find this right here, and what did you call it? V? B. Oh, okay, so she went with B right there, so she's going to go cosine of 16 degrees equals the adjacent side, which is B, divided by the hypotenuse, which is 18, and so if I multiply both sides by 18, I'm going to find out that B is 18 times the cosine of 16 degrees, which is about 17 meters. So now we know that this piece right here is 17 meters long. And then, okay. Nice, okay, and then now she's going to look at this triangle right here and use the tangent ratio to figure out what this missing piece is. We'll just call that h. So the tangent of 68 degrees is the opposite side, which is h, divided by the adjacent side, which is 17. So h is equal to 17 times the tangent of 68, or 42 meters. And so if this piece right here is 42 meters and the other piece is 5 meters, altogether the tree is about, excuse me, it's about what? 47 meters tall. Okay? Man, that's a lot of work.
Why so much work?
Bless you. Is there anyone that can tell me a way that we could have used the law of sines to do it faster? Nobody?
That's smart.
How do we figure out that? Oh, they told us that was 68? Okay, one thing that we could have done here to speed this along is, without breaking it down into the right triangles, is if I know that this angle right here is 16 degrees, and I know that this angle right here is 90 degrees, what's this angle right here going to be? Don't all say it at once. Let somebody get a chance. If this angle right here is 90 degrees and this angle is 16 degrees, what's this angle? 74. Okay, and so now I can look at this whole triangle right here. So I'd have to add these two angles together, and that really would be how much of an angle? 84 degrees. And then I know that this angle right here is going to be what? This is 84, this is 74, so together those add up to 158. 180 minus 158 is what? 22. 22, okay? All right, and so now I could use the law of sines, now that I know all the angles in this. So I could say the sine of 22 degrees, this angle up here, is equal to the length of the side opposite, or over the length of the side opposite it, is going to be equal to the sine of 84 degrees divided by the length of the side opposite that. And then we could figure it out from there too.
How do you do that?
Okay. Here I would go 18 times sine of 84 divided by sine of 22. Okay. But either one of those ways should work, and you should come up with about the same answer no matter how you do it. Do you like her way? Oh, the second one. Oh, okay. Whatever works. As long as you get the right answer.
Whatever, dude.
Whatever, dude. All right, number 14. Did you read the history connection?
I did. Of course.
Okay, it says one of the most impressive Mayan pyramids is El Castillo in, however you pronounce that, Mexico. Built in approximately 800 CE, it has 91 steps on each of its four sides. CE stands for current era. So that is the way the scientists say it instead of BC and AD, because those both have religious, you know, before Christ and Anno Domini, the year of our Lord, and so they just go with CE, current era. I don't know, man, because it's all this political correct stuff, and you can't say this, and you gotta say that, and you know, whatever. So you can say whatever you want. Say AD, you can say CE, or you can just go with 800, and we'll know the difference. What? Okay, anyway, it has 91 steps on each of its four sides. So there's these four sides to this thing, and to get up to the top, each one you would have to go up 91 steps to get to the top. Okay? Or 364 steps in all, because 4 times 91 is 364. The top platform adds a level, so the pyramid has 365 levels to represent the number of days in the Mayan year. And we all know that, you know, then they all destroyed their pyramids or something like that, and so we're going to die. I don't even know what. Okay, so 14 says, each step of El Castillo is 30 centimeters deep and 26 centimeters high. How tall is the pyramid, not counting the platform at the top? Well, so they're saying each step I have to go 30 centimeters this way, and I have to go, how much high? 26 centimeters high. So how would I figure out how high up total I go? Yeah, don't you just multiply it by 91? Because there's 91 steps and each is 26 centimeters high. Is this a trick question somehow? Oh, the angle we have to figure out. Okay, so 91 times 26 centimeters is how many centimeters altogether? Okay, so you would end up going up 2,366 centimeters to get to the top. But the main thing is they want you to figure out the angle that you would be hiking up. And so to do that, we need to think of it as being a right triangle like this. We just figured out the height of the right triangle is 2,366. What's the base of this right triangle going to be? What? 91 times 30, yep. Okay, so 91 times 3 is 273. Tack a 0 onto that, 2730. How do I find that angle right there?
The opposite of whatever.
Inverse, which one? Tangent, good, because this is the opposite side over here, and this is the adjacent side. So I'm going to go inverse tangent of 2366 divided by 2730. And what do you get when you do that? About 41 degrees. Which is surprisingly steep. That's really pretty steep. And you can kind of see that from the picture if you look at it a little bit. 41 degrees, I mean 45 degrees is here, so it's pretty steep. It doesn't seem like it when you say that number, but you'd be surprised. We'll take a field trip there.
Please?
Yeah, we can. I'll give you permission slips tomorrow. We'll leave on Monday.
Yes.
No, wait, even better than yet. The weather's bad. Let's leave on Friday. Okay?
Can't.
All right. So don't let me forget to get the permission slips out to you. All right, 15. According to legend, you've all heard of Galileo, right?
Yeah.
Okay. He used the Leaning Tower of Pisa to do science experiments. So basically what he would do is he'd go up to the top of the tower and he'd drop stuff off and he'd time how long it took to get to the bottom and things like that. And he was able to come up with all kinds of nifty scientific conclusions from that. So when he was dropping some of his objects from the top of the 55-meter tower, and when they say 55 meters, oh, let's not do that anymore. When they say 55 meters, they mean the tower itself, okay, was built to be 55 meters tall. They landed 4.8 meters from the tower's base. So you drop the thing down here, and it would land down here 4.8 meters from the base of the tower. What is the angle that the tower was leaning from the vertical? So we need to again find this angle right here. So which trig ratio do we need to use to find that? You did what? Oh, you used the law of sines? Okay. Tangent would be if we went the opposite side over the adjacent side.
So it's cosine.
Cosine, good. Cosine of theta is the adjacent side, which is 4.8 divided by the hypotenuse, which is 55. So I need to go inverse cosine of those things to figure this out. And what do you get from that? About 5 degrees. Okay, and you got that using the law of sines also? Okay. So you could have also done that. What she did is she knew that this was 90 degrees. And so she said sine of 90 over 55 equals, did you go sine of this one over 4.8 and then subtract or something? Okay, all right, good deal. So either way you do it, you come up with 5 degrees. What? Oh. Makes sense to me now. Okay, yes? I did?
Yeah. You get 5 degrees, you put opposite.
Oh yeah, because obviously this isn't 5 degrees right here, huh? That'd be like, what does that come up to when you go inverse cosine of 4.8 divided by 55? 84 point something, they rounded up to 85. Okay, so this angle right here is 85 degrees. I gotcha. Okay, so I guess then what they're saying is, what is the angle that the tower is leaning from vertical? What we measured is what the tower is leaning from horizontal. Okay, so you didn't have to do the subtraction thing. That was all screwed up there. So they want to know what's this angle right here. What is the angle from the vertical? And that's going to be 5. Okay? That's what they want to know.
It's 5 or 85?
It's 5. It's 85 degrees from the horizontal, but it's 5 degrees from being straight up. This thing right here.
So the answer is 5 to 1 over.
So the answer is 4.8 times 3 squared.
It's 5.
It's 5. Okay. All right, is that it?
16.
Do we do 16?
Yeah. 13 to
I signed it? Okay. That doesn't mean you did it, but I signed it. What?
5.
I will try. Wait, I have a question.
What's your question?
Italian back here.
Take a bit of the bigger.
It would look better at a little bit of a slant.
Doesn't make it straight, stable. Like lines, and then it's kind of tilted. And they're like, I think a little straight.
Okay, last one, number 16, we are asked to find the volume of that cone. So a good place to start, if we're asked to find the volume of a cone, is to figure out what the formula for the volume of a cone is. 1/3 the area of the base times the height, and then since it's a cone, the base is a circle, so the formula for the area of a circle is pi r squared. So we want to know what 1/3 pi r squared h is. But they didn't tell us what the height is, and they didn't tell us what the radius is, so how are we supposed to figure this out? Anna? Is what? You know the one next to it is what? Okay, so you know if this is 120 degrees, then this one right here is 60 degrees, okay? And so where'd you go from there?
That one's 90.
This is obviously 90 because the height is perpendicular to the base.
That's 30.
And so this one's 30 up here, okay? Now what? We could do the law of sines. Yeah, I could go sine of 90 over 3 equals sine of 60 over this, and use that to figure out what that is, right? And then you could do the same thing with this one. I could go sine of 90 over 3 equals the sine of 30 over that. Anthony? Okay, good deal. Yes, I could go sine of 60 equals the opposite side over the hypotenuse. So that's another way that I could figure that out. What's another way we could do it that's super easy? Lately raising your hand and stretching. Stretching, okay. What's true? This is a 30, 60, 90 triangle, right? So it has a special relationship between its sides. Right. Shh, shh, shh. The base of this one, or the side across from the 30-degree angle, is half of the hypotenuse. So if I can just remember that relationship, then I know that the radius is going to be 1.5, okay? And what is the long leg of a 30, 60, 90 triangle come out to be? 1.5 times the square root of 3, okay? So either way you do it, if you use the law of sines, or if you just use the straight up trig ratios, or if you remember your 30, 60, 90 triangle relationships, this is what you come up with for the radius, that's what you come up with for the height. So the volume is going to be 1/3 pi times 1.5 squared times 1.5 root 3, which should come out to be approximately 6 cubic centimeters. Okay?